Now one more example on Guass Seidal iterative procedure. Find the solution of the system of equation. Find the solution of the system of equation. System of equations. 45x1 plus 2x2 plus 3x3 equal to 58 minus 3x1 plus 22x2 plus 2x3 equal to 47, 5x1 plus x2 plus 20x3 equal to 67. Correct to 3 decimal places. 3 decimal places using Guass Seidal method. Using Guass Seidal method. Okay, this is the question. Solution. See, in the given system, this 45 is more than sum of these two. 22 is more than sum of these two. Next, 20 is more than sum of these two quotients. So, in the system, clearly diagonal dominance occur. Diagonal dominance property holds, right? Since diagonal dominance property holds, therefore write the system as from the first equation write x1. What is x1 equal to? 1 by 45 58 minus 2x2 minus 3x3, isn't it? From the second equation x2 equal to what? 1 by 22 47 minus plus 3x1 minus 2x3. From the third equation x3 equal to 1 by 20 of 67 minus 5x1 minus x2. Okay, using the diagonal dominance. This is from first equation. This is using second equation, and this is using third equation. Now what is Guass Seidal iterative formula? Now Guass Seidal gives the iteration formula. What is that? x1 value at k plus 1th iteration is equal to 1 by 45. This is 58 minus 2x2 at what? Kth iteration. 3x3 at what? Kth iteration. Now x2 value at k plus 1th iteration is 1 by 22 47 plus 3x1. Now I know the x1 value at k plus 1th iteration. So here you have to write k plus 1th iteration minus 2x2. Update value is used in Guass Seidal method. This is the logic. Next one, x3 at k plus 1th iteration is 1 by 20 of 67 minus 5x1. Now x1 is known at what? K plus 1th iteration. Next one, x2 is also known at what? K plus 1th iteration. So x2, x1 and x2 both replaced by k plus 1th iteration. This is Guass Seidal iteration method. Start now. Assume, since initial approximation is not given, whenever initial approximation is not given, assume it as 0. Assume the initial approximation as initial approximate solution as x1 0 equal to x2 0 equal to x3 0 equal to 0. If it is not given, assume it as 0. Then let me start with first iteration. First iteration, this is for k equals to 0. So what is the value? x1 value 1, x1 at first iteration, 1 by 45, 58 minus 2x2 at 0. Next one, minus 3x3 at 0. Since x2 x3 is 0, this is 58 by 45, this is 1.28889. Next one, x2 value at first iteration is 1 by 22, 47 plus 3, x1 at first iteration, minus 2 x3 at 0th iteration. This is 1 by 22 of 47 plus 3 into what is x1 at first iteration, 28889, and x3 is 0, so 0. This is equal to, the value is 2.31212. Now x3 at a first iteration is equal to 1 by 20 of 67 minus 5, x1 at first iteration minus x2 at first iteration. Substitute those two values. 1 by 20, 67 minus 5 into 1.28889 minus 2.31212. This value is 2.91217. This is first iteration. Coming to second iteration. This is x for k equals to 1. Now x1 value at second iteration is 1 by 45, 58 minus 2x2 at first iteration, 3x3 at first iteration. Because first iteration values are known, you substitute all these values. Just I am giving the value 0.99198. Now x2 value at second iteration, 1 by 22, 47 plus 3x1 at what second iteration, updated value is used here, minus 2x3 at first iteration. So this values after substituting x2 at second iteration is 2.00689. Coming to x3 at a second iteration, that is equal to 1 by 20, 67 minus 5, x1 I know at second level, and x2 is also known at second level, so substitute at second iteration values, then the result is 3.00166. This is second iteration values. Coming to third iteration values. This is x1 at a third iteration, 1 by 45, 58 minus 2x2 at a second iteration, 3x3 at a second iteration, because previous values are known here, and this value is 0.99958. Next one, x2 value at a third iteration, this is 1 by 22 of 47 plus 3x1. Now I know this value at third iteration, but x3 is known only at second iteration, so this value is 1.99979, and x3 at a third iteration, 1 by 20, 67 minus 5x1 I know at third iteration, x2 I know at third iteration, so third stage solution, and the result is 3.000012. Next one, fourth iteration. X1 value at fourth iteration is equal to 1 by 45, 58 minus 2x2 at a third level, minus 3x3 is also at third level, previous level values, and this result is 1.0. And x2 value at fourth iteration is 1 by 22, 47 plus 3x1. Now x1 is known at fourth stage, so 4 x3 is known at third stage only, and the result is 1.559. Next one, x3 value at fourth stage is 1 by 20, 67 minus 5x1 at fourth stage known, and x2 is also at fourth stage known, So this value is 3.000, right? This is the fourth iteration. Now let us see whether 3 decimal accuracy is acquired or not. Now we find for the first one. For the first one, we find what is that x1 at fourth iteration minus x1 at third iteration. The difference between two successive approximations. Successive here, third and fourth approximations. Their difference and absolute magnitude. This is what is this is 1 minus x1 at the third stage is what? 3958. What is this value? 0.00042. Clearly, this is less than 0.0005. Coming to x2 at fourth stage minus x2 at third stage is equal to x2 at fourth stage is what? 1.59 minus third stage is 1.3979 and the result is 0.00020. It is also less than what? 0005. This is 3 decimal accuracy and 5 must be there, remember this. And x3 at fourth iteration, x3 at third iteration, the difference is this is 3 minus 3.00012 and the result is 0.00012 and this also less than 0005. Okay, that means since all the errors in magnitude, means forget about the sign, in magnitude are less than 0.0005, the required 3 decimal accuracy, is achieved. 3 decimal accuracy is achieved. Therefore, what is the solution? Therefore, solution is, what is x1 value at fourth stage? 1. x2 value is what? 1.59 approximately 2 and x3 value is what? 3. That's it. This is one problem, right? And let us see another problem. Just I will not complete I will not fully solve this problem, just I will give hint. Computationally show that Guass Seidal method applied to the system 3x1 minus 6x2 plus 2x3 equal to 23 minus 4x1 plus x2 minus x3 equal to minus 8, x1 minus 3x2 plus 7x3 equal to 17 diverges. That means Guass Seidal method not converging, diverges. Next, take the initial approximation. As x1 equal to 0.9, x2 equal to minus 3.1, x3 equal to 0.9. Okay, and one more. Okay, later on I will give hint. Let us see the solution. What is the Guass Seidal? Now the given system, first observe the system. The given system is not diagonally dominant. You can observe the system, it is clearly not diagonally dominant. Then from the first expression, if I write xk plus 1, not diagonally dominant. Observe this. Let us solve as usual this problem. From the first equation, From the first equation, what is x1 value? 1 by 3, 23 plus 6x2 minus 2x3. From the second equation, what is x2 value? X2 is directly 8, okay, minus 8. X2 na minus 8 plus 4x1 plus x3. That's it. From the third equation, what is x3 equal to? x3 equal to 1 by 7, 17 minus x1 plus 3x2. Therefore, Guass Seidal iterative formula is x1 at k plus 1th iteration is equal to 1 by 3, 23 plus 6x2 at kth iteration minus 2x3 at kth iteration. Similarly, x2 at k plus 1th iteration is equal to, just this is minus 8 plus 4x1 at what iteration? x1 k plus 1 and x3 at kth iteration. And lastly, x3 k plus 1 is 1 by 7, 17 minus x1 at k plus 1th iteration plus 3x2 at k plus 1th iteration. This is Guass Seidal iterative formula. Okay. Now see what happens here. First iteration. For when k equals to 0, what is this value? x1 at first level. This is 1 by 3, 23 plus 6, x2 0 minus 2, x3 0. And what are the given initial approximations in the problem? It is given 23 plus 6 into this is minus 3.1 and minus 2 into x30 is taken as 0.9. x3 is taken as 0.9. Now after simplification you will get 0.8667. Next one, x2 at first iteration equal to minus 8 plus 4 x1 at first iteration plus x3 at what? 0th iteration. If I substitute all these values, I am getting minus 3.63332. Next, x3 at first iteration 1 by 7, 17 minus x1 I know at first level plus 3x2. x2 is also known at first level, so write first level and substitute all the values. The result is this one. Now second iteration. See what changes occurs in second iteration. This value is x1 at second iteration 1 by 3, 23 plus 6x2 first minus 2x3 first. Okay, and the result is minus 0.0982. What is this value? First 0.8667, but it is very far to 8667, not at all closer, very far, right? Similarly, x2 at second iteration is minus 8 plus 4x1 at second iteration, x3 at first iteration, and this value is minus 7.6451. This is minus 3 point and this is minus 7 point. And x3 at second iteration is 1 by 7, 17 minus x1 at second iteration plus 3x2 is also at second iteration. So this value is minus 0.8339. See, this is 0.744 and this is minus 0.83, not at all comparable. Let us see what happened at the third iteration. Third iteration means k equal to 2. Then x1 value at a third stage 1 by 3, 23 plus 6 x2 at second level minus 2 x3 at second level. This value minus 7.0676, where again oscillate. This is previous value is what? Minus 0.0982. Now this is minus 7 point. Now x2 value at a third stage is minus 8 plus 4x1 at a third level. I know third level value, but x3 at second level value, this is minus 37.1043. So not at all we're closer, it's going on. And x3 value at the third iteration is 1 by 7, 17 minus x1 at third level plus 3x2 at the third level, 3x2 at third level, this is minus 12.4636. Therefore what is observation? Therefore we observed that the iterations are diverging very fastly, very fast. Okay, therefore Guass Seidal method diverges. But what is the remark here? Now let us see this remark. For the convergence, we have to interchange the equations. To get diagonal dominance property. We have to interchange the equations to get the diagonal dominance property in the given system. So what is observation? How to interchange? Let us interchange first and second equations. Next one, let us interchange first and the second equations. Then we have what we have. Second equation is now becomes first equation, equal to minus 8. First equation becomes now second equation, 2x3 equal to 23. Third equation as usual, minus 3x2 plus 7x3 equal to 17. Now see, observe, this is the diagonal value is more than sum of these two. This is the diagonal value more than sum of these two. This is the diagonal value more than sum of these two in magnitudes. Clearly diagonal dominance exists. Then this system converges. Okay, now you solve this system. I am giving the answer at the last fourth iteration. I am giving after four iterations, solution is x1 equal to 0.9998, so approximately 1, x2 equal to minus 3.0002, so approximately I can take 3, minus 3. Next one, x3 equal to 0.49, so approximately 1. This is the solution. You solve this by using again Guass Seidal method. Now the last iterative method is successive over relaxation method. Successive over relaxation. This is called SOR, successive over relaxation method. Okay, and what is this method? See, this method is a generalization of Guass Seidal method. Generalization of Guass Seidal method. And the method is often used when the coefficient matrix of the system of equations, quotient matrix A of the system of equations is symmetric and has the property A. Symmetric and has the property A. This is property A. Okay, and let us see what is property A later on. Symmetry means you know A equal to A transpose. Now let us define an auxiliary vector. Define an auxiliary vector or fictitious vector. This is x cap as, how we define this x cap at k plus 1th iteration equal to minus D inverse diagonal matrix inverse into L lower triangular matrix of x k plus 1 minus D inverse U of x k plus D inverse B. You have to remember this. What is this? X cap of k plus 1th iteration value is what? Minus D inverse L x k plus 1th iteration minus D inverse U x at kth iteration plus D inverse B. Take this as equation 1. Now the final solution can be written as x k plus 1. This is our final solution equal to x k plus omega into x cap k plus 1 minus x cap k plus 1 minus x cap k plus 1 minus xk. Okay, and in this one I can take this xk common. Okay, the next step is, this implies xk plus 1 is equal to 1 minus omega xk plus omega x cap k plus 1. Omega x cap k plus 1. This is equation 2. Okay, here omega is called relaxation parameter. Something called weight function. It is called weight function. In operation research, you know what is convex function. Convex function means any vector can be written as convex combination, right? Do you remember? Lambda 1 x1 plus lambda 2 x2. Convex combination of these two functions x1 and x2 where lambda 1 plus lambda 2 equal to 1. Convex combination, beginning of the operation research chapter. So sum of this 1 minus omega plus omega is 1. So xk plus 1 is called convex combination of xk and x cap k plus 1. Okay, and omega generally taken as weight function. Sometimes it is called relaxation parameter. Now substituting 1 in 2 and simplifying we obtain what is this 2 implies xk plus 1 is equal to d plus omega L whole inverse bracket 1 minus omega d minus omega u bracket xk plus omega into d plus omega L whole inverse b. This can be taken as, this implies xk plus 1 is equal to this entire h of xk plus c, k equals to 0, 1, 2 and so on. This is equation 3. This one, our iterative formula in matrix form, you know this one, where now you have to remember this, where what is h? Iterative matrix. H is d plus omega L whole inverse multiplied by 1 minus omega d minus omega u. This is H matrix. And the C matrix column vector is omega into d plus omega L inverse into B. Okay, and this equation 3 alternately, this is called, this is what one can write, you remember this formula, this is called equation 3 is SOR method in matrix form. Now let us see error form. Now equation 3 can be written as xk plus 1 equal to xk, adding and subtracting xk like previous method, xk, then d plus omega L, you have to add and subtract xk and take common, d plus omega L whole inverse, like in Guass Seidal method, d plus omega L minus 1 minus omega d plus omega u, this whole xk, plus omega into d plus omega L inverse b. This implies xk plus 1 is equal to xk plus omega into d plus omega L whole inverse rk, where what is rk, you know, residue b minus a xk is the residue, okay. Then therefore what we have finally, and you write xk plus 1 minus xk equal to omega into d plus omega L whole inverse r power k. So what is this one? As usual, our notation, vk into equal to omega d plus omega L inverse r power k, okay, is the SOR method in error format, okay. First find vk, then find xk plus 1 using xk plus 1 equal to vk plus xk, using this formula, vk value, okay. What is vk here? Vk is what? xk plus 1 minus xk, so xk plus 1 is this value, okay. And one more point, when omega equal to 1, then SOR method is Guass Seidal method, is equal to Guass Seidal, and what is this one xk? Okay, we find the weights here. The weights omega are non-negative, that is omega lies between 0 and 1, and if omega is greater than 1, then SOR method is called an over relaxation method, and if omega is less than 1, SOR is called, successive over relaxation method is called an under relaxation method, okay. This is the information. Depending upon omega greater than 1 and less than 1, over relaxation method and under relaxation method. Just remember the procedure only. Problem will not be given in SOR method because it is very big, okay. This is your second unit completely.